When you look at the night sky, you see stars and galaxies scattered across the darkness. Random, beautiful, but seemingly chaotic. But if you could zoom out far enough, beyond the scale of galaxies, clusters, and even superclusters, a hidden order would emerge. An enormous, interconnected structure, like a spider's web woven from galaxies and gravity. This is the cosmic web, the vast skeleton of the universe. It stretches across billions of light years, made of filaments of dark matter, gas, and galaxies, interspersed with massive voids, empty expanses where few galaxies exist. It's the universe's large-scale structure, and understanding it reveals deep truths about how the cosmos evolved. A universe of structure. Shortly after the Big Bang, the universe was hot, dense, and nearly uniform, except for tiny quantum fluctuations. These minute variations in density became the seeds of all future structure. As the universe expanded and cooled, gravity amplified the denser regions, pulling in more matter and forming the first stars and galaxies. Over billions of years, this process created galaxies, clusters of galaxies, superclusters, and eventually the cosmic web, the largest pattern in the universe. Today, massive filaments stretch like tendrils across space, connecting galactic clusters. At the intersections of these filaments lie the most massive structures, nodes, where clusters merge and collide. And in between, enormous voids, often hundreds of millions of light-years across, almost completely empty. Mapping the invisible. We can't see the cosmic web with our eyes, but we can trace its outlines. Telescopes like Sloan Digital Sky Survey, SDSS, and upcoming missions like Euclid and the Vera C. Rubin Observatory scan the skies, mapping the positions and redshifts of millions of galaxies. These galaxies serve as markers, revealing the underlying structure. But the true scaffolding of the web isn't made of stars. It's made of dark matter. Simulations like the Millennium Simulation and Illustris TNG show how dark matter forms long filaments, with galaxies forming along them. This web-like pattern arises naturally from the physics of gravity and the distribution of matter after the Big Bang. It's a cosmic fingerprint. Studying the web, astronomers and physicists use the cosmic web to test theories about dark matter and how it interacts, dark energy and how it affects cosmic expansion, neutrino mass, which influences structure formation, primordial fluctuations from the Big Bang. By analyzing the geometry, growth, and distribution of the web, scientists can reverse engineer the forces that shaped the cosmos. It's like reading the history of the universe in a vast, invisible script. Cosmic filaments and the warm-hot intergalactic medium, WEM. Within the web's filaments lies a puzzle, the missing baryons. Astronomers know how many protons and neutrons should exist, but nearly 40% of them are unaccounted for. Where did they go? The answer may lie in the warm-hot intergalactic medium, or WIM. This is gas at temperatures of 10⁵ to 10�07 Kelvin, stretched along the filaments of the cosmic web. Recent observations using X-ray telescopes like Chandra and ESA's XMM Newton have begun detecting this hot gas, confirming that the WHIM may indeed house the universe's missing normal matter. This gas is too diffuse to form stars, but it's critical to understanding how galaxies evolve. Cosmic web and life? The cosmic web isn't just a structure. It may influence where life can arise. Galaxies near the nodes, where filaments intersect, tend to be larger, older, and richer in elements needed for planets and biology. Meanwhile, galaxies deep within voids are often smaller, younger, and less chemically evolved. This suggests a cosmic bias, where some regions of the universe are more likely to harbor complex life than others. Some even speculate that our place in the web, not too close to chaos, not too far from richness, is part of the anthropic principle. We exist in a region where conditions allow observers to emerge. Could it be conscious? Here's a strange idea. The structure of the cosmic web, with its branching filaments, nodes, and signals, has been compared to neurons in the human brain. A 2020 study found that the topology of the universe and the brain's neural network are strikingly similar, both displaying a balance of information flow and clustering. Is it coincidence? Or could the cosmos be conscious in some way? A thinking structure, not in the traditional sense, but as a system of emergent complexity. We don't have answers, but the comparison stretches our imagination. What it teaches us. The cosmic web teaches us that the universe is not random. Even across billions of light years, there is structure, order, and beauty, sculpted by gravity, time, and the physics of the early universe. It also reminds us how small we are. Our galaxy is just one bead on a filament, one dot in a sea of voids and clusters, part of a structure so large it takes light billions of years to cross. But in mapping this web, in understanding its intricacies, we fulfill a deeply human purpose. To find patterns, to discover meaning, to see the invisible, and know we're part of something far grander than ourselves.